Hi, Algebra 1. In Lesson 22, we are still graphing linear inequalities, but today we're going to look at a few word problems and make sense of the solutions by thinking about the context of the problem. Our first couple of problems are all about landscaping. So this first problem says, a homeowner is making plans to landscape her yard. She plans to hire professionals to install grass sod in some parts of the yard and flower beds in other parts. Grass sod installation costs $2 per square foot and flower bed installation costs $12 per square foot. Her budget for the project is $3,000. So we are going to graph all the different possible combinations of grass sod and flower bed that she can install if she uses her entire budget. So before we can graph it, we need to write an equation. They tell us to use x as the variable for grass sod and y as the variable for flower beds. So when we're writing our equation, we're going to start with that total amount. And in this case, that total amount is her budget of $3,000. We know grass is $2 per square foot, so that would be 2x. And we know flowers are $12 per square foot, so that would be 12y. So we have our equation. We can graph that on the grid down below. So on this grid, they labeled our x and y axes for us already. We could graph this equation by changing it to slope-intercept form and making that equation say y equals. But another possibility is that we can just figure out some different points that are solutions to this problem and plot those points until we can see what the line would look like. So if we start with some easy ones, if she decides that she does not want any grass in her yard, she's going to go all flowers. So if there's no grass in this yard, it would be 2 times 0 plus 12y equals 3,000. This would tell us how many feet of flower bed she can have if there's no grass. Well, 2 times 0 is just 0. So we get 12y equals 3,000. When we divide by 12 on both sides, we get that y is 250. So this tells me if there is no grass, we can have 250 square feet of flower beds. So on the graph, that would be 0, 250 right here. So now if we think about it the opposite way, what if there are no flowers and it is all grass in her yard? So that would be 2x plus 12 times 0, because now there are no flowers here, equals 3,000. 12 times 0 is just 0. So I get 2x equals 3,000, which means x equals 1,500. So no flowers, 1,500 square feet of grass, that would be right here. So that gives us 2 points. We can grab a ruler and make a line. If you don't feel confident making your line, we can figure out another point on the graph. So let's pick another number to go with. Let's say she does 600 square feet of grass. We can figure out how many square feet of flowers that will leave her with. So if it's 600 square feet of grass, that's 2 times 600 plus 12y equals 3,000. 2 times 600 is 1,200, so 1,200 plus 12y equals 3,000. Let's see, subtract 1,200 on both sides. We end up with 12y is equal to 1,800. When both sides get divided by 12 here, we end up with y is equal to 150. So that tells me if there are 600 square feet of grass, there's 150 square feet of flower beds. So it just gives me another point that I can use to graph that line. So any point on this line, any of these points, doesn't matter which one we look at, these are all possible combinations of flower beds and grass that would come out to exactly $3,000. Any of these points on the line. They all equal exactly $3,000. In the next problem, we're landscaping. But now she's kind of changed her mind. She thinks that it's too much work to have grass in flower beds. So she is considering getting artificial turf, which is $15 per square foot, and gravel, which is $3 per square foot. She's going to use a combination of the two of them, and her budget is still $3,000. This time they made the graph for us, which is nice. We don't have to worry about finding points to plot. So the line on this graph represents all the combinations that total to $3,000 when she's using grass and artificial turf. So if we look at the first question, the graph shows a line going through 500, 100. In this situation, what does that point actually mean? So if we look at our x and y axis, our x-axis is gravel. So that tells me that's 500 square feet of gravel. The y-axis is turf, so that's 100 square feet of turf. So what that point means is we get some gravel, we get some turf, and because that point is on the line, together we know that equals $3,000. That's a combination that takes up her whole budget. If we had to write an equation that our line represents, we know it's still going to equal $3,000. That's still her budget. That hasn't changed. What did change is that now, instead of doing grass and flower beds, she's doing gravel, which is $3 per square foot, and turf, which is $15 per square foot. Any solutions to that equation are combinations of grass and sod. Nope, lies. Combinations of turf and gravel that would equal $3,000. So now we're going to look at some points that are not on the line. We know points on the line come out to $3,000. But what about this point up here at 600, 200? We know that point means we have 600 square feet of gravel and 200 square feet of turf. This first question is asking if that combination meets the homeowner's constraints. Remember, her constraint is her budget. Does that fall within her budget of $3,000? And this definitely does not. I know this doesn't meet the budget of $3,000 because it's not on the line, but I can also plug those values into the equation that I wrote and see that this is going to come out to more than $3,000. 3 times 600 is 1,800. 15 times 200 is 3,000. That's definitely going to be more than $3,000. That's not equal to $3,000. This ends up being $4,800. So that's over her budget. And if we check any other point up here, all of these points are also going to be over her budget. Constraints. Well, here's 200, 100. I know that point does not meet the constraints needed to graph this inequality. I'm still going to have a solid line because it's still less than or equal to. So this won't change. But now to show all the possible combinations, I have to shade the part of the graph that is less than or equal to her $3,000 budget. And that would be this part of the graph right here. These are all combinations that cost less than $3,000. If we look at a point on the other side of the line, this one's asking us to look at the point 200, 100. Same questions. Does that point meet because it's not on the line? All the points that meet the constraints are on the line. If we chose any other point that's over there, we would end up with a combination that costs less than her $3,000 budget. And we can see that if we plug in our 200 square feet of gravel, our 100 square feet of turf, this is not going to equal $3,000. 3 times 200 is 600. 15 times 100 is 1,500. This only ends up coming out to $2,100. So that's below her budget. If we're thinking about her budget as an inequality, she doesn't need to spend all $3,000. She could spend less than that. So if I had to turn this into an inequality, it's still going to be 3x plus 15y. But now instead of equal to 3,000, I can change that to less than or equal to. She could spend the whole budget. That is an option. But she doesn't have to spend it. She could spend less than that. So that would change our graph a little bit. For the next word problem, the Saturday market problem, we have a vendor that makes $9 of profit on each necklace that she sells and $5 of profit on each bracelet. So I want you to try this one on your own and then come back and check your answers. But first, let's define some variables. We'll let n be the number of necklaces. And we'll go with B for the number of bracelets that she sells. Pause the video. Go through question 1, 2, and come back and check your answers. Okay, hopefully you have checked your work. So we are here where we have N necklaces and B bracelets. To get exactly $100, here are a couple of possible combinations. She could sell 0 necklaces and 20 bracelets, 10 necklaces and 2 bracelets, 5 necklaces and 11 bracelets. Those all come out to exactly $100. To get more than $100, we could fill in a bajillion different combinations as long as it's more than any of the combinations we already have. So to turn that into an equation, we would have 9n plus 5b is equal to 100. That gets us exactly $100 in profit. 2, 3, and 4 go up to the point where you're graphing your inequality. Try this on your own first, and then when we look at number 3 asks you to write an inequality so that she makes more than $100. So that just changes the symbol from an equal sign to a greater than sign. When I had to graph the inequality, I plotted those 3 points that gave me exactly $100, and those form my boundary line. In this case, because it's going to be greater than 100, I know that it's going to be a dashed line. And then to color in the side that's greater than, it's just all those combinations that would be more than $100. The last question asks, is 3, 18.6 a solution to the inequality? Explain your reasoning. If we look at that point on the graph, 3, 18.6 would be like in here somewhere. So technically, yes, that is in the shaded in part of the graph, but in reality, you can't sell 18.6 bracelets. Okay, that's the last part of lesson 22 I'm going to go through with you in the video. There is another problem here about a charity concert. I highly recommend you go through this problem. I'll post the filled in answers on Classroom so you can check your work on this one. But your official homework is to, oh, you should read the summary, but the official homework is to do the lesson 22 practice problems.